Hey guys, welcome back. In this video, we're going to talk about lighting up RIPng in a VRF. Now, we've all been down this road. We've all been required to essentially say, hey, look, when we receive routes in from this particular interface, I want to dump it into its own VRF because maybe these two networks here or these two segments are the only two that can see each other. Maybe we have a LAN segment off of here and this guy is in one VRF and he can't see this LAN segment over here that's in another VRF. Look at that, I can write on an angle. We've all had to perform this segmentation in our lifetimes as network engineers, and we need to understand how to do this in all of our protocols as well as RIPng. You can't treat RIP as a protocol that you're going to ignore. You have to know how to do this in various different routing protocols, essentially all of them, because at some point somebody's going to tell you, hey, we're having a problem, we can't figure out what happened, we're having a routing issue or whatever, and you're going to look and you're going to see, trust me, that somebody's running RIP, and you're going to say, really? You're running RIP? And it could be version 2, you might be lucky, but it also might be NG, it might be version 1 if you're really unlucky. You need to understand this. So what we're going to do is we're going to go ahead and we're going to get a RIP peering up between router 2 and router 3, router 2 and 4 rather, and what we will do is we will have a global process first, and I'm drawing in while I talk. We're going to have a global process first, and then we're going to convert it to a VRF. So right now I'm drawing in some IP address information so that you guys understand exactly how we're going to set this up. So we'll have loopback 0 interfaces, and these guys are going to essentially be what we use to test reachability. They'll be /128s. We'll have 2016, : and then the router number. So it would be : 2, : 4. These guys will be /64s. And what we're going to do is we're going to essentially put this guy and this guy in its own VRF. And let's just say we'll call that VRF, we'll say VRF RIPng. Okay, so we'll have it's RIPng VRF, and that way all of those routes going back and forth between router 2 and router 4 will essentially only on router 2. Router 4 will see them in his global table, but router 2 will dump them into a VRF so that essentially everybody else in RIP will not receive them or understand them or get them. All right, so first thing we need to do, IPv6, unicast routing. No sense in turning on RIP if we don't have IP addresses, right? But I mean, we can if we want to. It's really up to you. You could say IPv6 router RIP. You could say RIPng. You could say redistribute connected, which is generally how you might set up RIP. But essentially here, nothing's going to happen because we haven't set up IP addresses. We haven't enabled it on the interfaces. So we'll say interface L0, IPv6 address 2017 : 22/128, interface E01, IPv6 address 2016 : 2/64. While I'm in here, I can say IPv6 RIP, and I can say RIPng. Whoops. Incomplete command. Enable. There we go. So do show run interface E01. Good to go. We can say, actually, you know what? Let's say interface L0, and let's actually pop this guy. No, we'll leave it as redistribute connected. That'll be a little bit more fun later on. So let's say do show run section RIP. Validate our configuration. Let's go ahead and pop this guy over on router 4. We'll just keep that in the buffer. We'll say config T, IPv6 unicast routing. Enable that. Interface L0, IPv6 address 2017 : 44/128, and interface E01, IPv6 address 2016 : 4/64, IPv6 RIP and RIPng. Enable. Now, one quick thing. At this point, if you guys are watching all the RIPng videos, you should be good and comfortable with looking at things like show IPv6 interface brief E assigned. Oops, forgot admin down. You guys should be comfortable understanding that this is the link local address and this is the global unicast address. You should be comfortable understanding that right here at this point we should be able to ping, and you should be comfortable knowing that we don't need IPv6 unicast routing in order to enable the IPv6 addresses as we've just done. Okay, so at this point, let's say do show IPv6 route RIP. And we have the loopback address from router 2. Let's check 2. Do show IPv6 route RIP RPI. I don't even know what that means. And we have the loopback address from router 4. So now comes the requirement down the pipe, hey, engineer so-and-so, we need to start dumping these routes into their own VRF. There's a security hole or the subnet needs to be, isolated, whatever it may be. We're running RIP. We're running RIPng. How do we get this guy over into his own VRF? So let's go ahead and let's make that conversion. Now, a lot of folks that are not comfortable with, I would say, IPv6 VRFs instinctively want to come in here and do something like this, RIPng, right? And let's say route distinguisher, we'll say because this is on router 2, we'll say 2.2, and they say exit. Do show run section VRF. And, a lot of people say, okay, we're done. You're not done because this is just IP. This is just for IPv4. This has nothing to do with IPv6. And so now they say, oh, what should we do? But, there is a command that you can use to essentially fix this, and it's called upgrade CLI. So what this will do is this will actually, I forgot there's a lot more to it. I hit enter prematurely. What you're going to do is you're going to say multi-AF mode, which stands for multi-address family mode, and then you're going to go ahead and you're going to say whether you want a common policy or a non-common policy, okay? Now, what this means is if you were using route targets, let me write that, we'll jot it down over here. So if you were using route targets, normally you would have your import and you would have your export, right? Well, what you can do is you can have separate import and exports for IPv4. I was saying IPv4 and I was writing IPv6, so there we go. You can have separate import and export values for IPv6 and IPv4, or you can have the same policies, and that's what this means. Do you want to share a common policy here? In other words, do you want to have the same route target import and export value for both IP versions, or do you want to separate them separately? Because, maybe in a layer 3 VPN, you want an IPv6 prefix to be imported here, and you don't want it to be imported here. But if you go ahead and you say import, 1:1, it's going to include both everywhere. So you have that option to do whatever you want. We don't really care here, so we're going to go ahead and say common policies. The last option, now I could just hit enter here if I want to, but I thought here that it would give me, I did say common policies already. My fault. Common policies. So here you can either force this and say, listen, don't prompt for confirmation, which, absolutely you can do if you already know that you're going to do it. But notice it peels off the other option for a specific VRF. So if you want to light up a specific VRF, so maybe you have 14 different VRFs and you're only doing one of them, you can say that specific VRF and then you can say force. So it's really just which one you put first. If you specify the VRF first for that one particular VRF, I mean, essentially we don't need this because we're only running one VRF. I'm just showing you the option. We can go ahead and say enter, and it says, hey, we succeeded in upgrading your one VRF. But let's take a look at what it did. We'll say section VRF, and you'll see here that it only did IPv4. We're still not done because we need to activate this for IPv6. Okay, so at this point, now the VRF is actually up and running. Let me actually go ahead and remove this for a second. And let's say do show VRF. Take a look at the protocols. What's it active? What's active? Only IPv4. The reason is because right now, if I say do show run section VRF, we only have an IPv4 address family that's actually configured. So even though there's nothing underneath it, even though there's no route targets, we're not doing route leaking, we're not doing anything, the address family has to actually be there and configured in order for it to be active. So in order for us to fix this, we'd have to go in and say IPv6, and then we say do show VRF. You can see now that it's active for both IPv4 and IPv6. Essentially, if you're just doing IPv6, you don't really need IPv4. In fact, we could remove it, and it's really not the end of the world because here we're only worried about IPv6. But what would happen is that when you go to the interface, let me actually show you, we'll do it. What will happen is when we go to the interface, it will remove both of the addresses when we apply the VRF, and then we will not be able to reassign the IPv4 address until we activate this address family. So what we want to do now is on Ethernet 01, we want to go ahead and we want to add this guy. So we'll say interface E01, do show run interface E01. And the reason why we're going to pull this up is because if we do not, we won't be able to see what IP address and subnet mask information was there. So you want to be able to see this when you do it. We'll say VRF forwarding, and then we're going to go ahead and we're going to pop in the name of our VRF. The minute we hit enter, boom, it lets us know, hey, both IPv4 and IPv6 addresses have been removed. Now notice we had RIP up and running on this interface. Let's actually see what happened now. Let's say do show run interface E01, and it also peeled off the RIP process. So we have to go ahead and reconfigure this, and the reason is because now we have to configure RIP in a VRF. So the iOS basically removed everything off of this interface, and it just left us with the VRF. So let's try the IP addresses first. So let's pop on the IPv6 address first. No problem, right? Not a big deal. Let's try the IPv4 address. Now it's going to give us an error. It's going to say, hey, we can't do this because you don't have an IPv4 address. Now I'm going to leave this alone. I essentially don't care. Well, might as well show you. So if I go back into this VRF, let's say VRF definition, address family IPv4, interface E01, and basically pop on this address again, now I have no problem. If I say do show VRF, now it lets me know, hey, your interface is active E01, both IPv4, here's your route distinguisher. So be careful there with what address families. Don't let this throw you. It's okay if this happens if you're only interested in IPv6. It's not the end of the world, all right? Now the last thing we need to do here, let's scroll up and find our interface, is let's go ahead and enable RIP for our VRF. Now I'm going to warn you here, this is going to give us an error. It lets us know that this is not enabled globally. RIPng is kind of a red-headed stepchild where we have to enable it globally as well as on the interface. Okay? And this is the same case with a VRF as well, but we have to essentially enable two things globally. We have to enable the process globally as well as the VRF mode. Now, if you forget, it's okay because the command that you're going to do here is going to be IPv6, and then it's going to be RIP VRF-mode followed by enable. So, and that's a command, you know, after years of doing it, it's going to be popped into your brain forever. I'm sorry. It is what it is. But the error message even tells you, it says, hey, look, you know, VRF mode. If you remember that essentially IPv6 RIP, you'll be able to question mark your way through it, I promise. So let's go ahead and do it. IPv6 RIP, and let's question mark our way through. There's only one option, VRF mode. Question mark, there's only one option. Boom, we're done. Let's go into our interface now, interface E01, and let's actually enable RIP. Now we're done, okay? So at this point, if I say show IPv6 route RIP, I don't get anything because at this point, all of my routes are now coming into a VRF, right? So here I would have to say show IPv6 route VRF and then use that VRF that I'm looking for. So here I would say RIPng, and then I could isolate it out. I could either say just show me everything, which again, here's the connected routes that we have, or I could filter this out and say show me the RIP routes that you're getting. So here are the RIP routes that I'm getting. Let's do a debug. Debug IPv6 RIP. Let's turn this on. Let's go to router 4. We can see that we have the loopback here of router 2, right? Let's say do debug IPv6 RIP, and let's actually see what's going on here. Let's say do show IPv6 route RIP. The loopback disappeared. We had it here, right? Now it's disappeared. So now we're going to run a debug. Let's see what happens. Let's say on all here. Let's take a look at the update that we're sending. So we received an update. So we received these two updates from router 4, right? Let's take a look at what we sent. So sending a multicast update, and was anything included? No. So in doing this conversion to a VRF, we've essentially lost our ability to send that loopback address that we were looking for. So remember, we have this loopback address here, 2017::22, that we're sending to router 4, and at this point, we've actually lost that ability. So there's a reason for this, and the reason is, if we take a look at our RIP process, you can see that we have our redistribute connected underneath our global process, but we're running this underneath a RIP instance, under a VRF instance now. So what we need to do is we essentially need to move this redistribute connected into a VRF because the interface that's facing router 4 is now in a VRF. So we're not able to essentially run anything outside of that VRF, essentially, because of the way we have this set up. We don't have any other RIP adjacencies. So what we're going to do is we're simply going to go and say no redistribute connected, and we're going to move this redistribute connected command underneath our VRF instance. So let's say exit, do show run section rip, and now you can see that we're going to say, hey, I want you to redistribute your connected prefixes for this VRF. Now let's take a look at what's happening. Do debug Ipv6 Rip, and let's see if we get any of these updates. Look here, we received one a couple of seconds ago, and we still did not have any information regarding that loopback address. We're still missing something, okay? I'm going to let you know that right now. We're still missing something. So we're still not getting these updates. We've gone and moved our redistribute connected command, but the last thing we need to do, let's say do show VRF again. What do you think is going on here? Look, here's us sending again. You can see we're sending this update, and again, nothing. What do you think is going on here? If we take a look at our VRF output, we have this interface in a VRF, right? So we're trying to advertise another network, this loopback 0, into a VRF. But this is in our global routing table, right? If I say show IP route connected, where's our loopback 0, right? Oh, sorry, show IPv6 route connected. Control AS. And we'll say connected. Okay, where's our loopback 0? Our loopback 0 is in our global routing table. And so we cannot, I mean, we can, but not in this video. We're not going to be able to take this connected route here and pop it into our VRF routing table, right? Using just RIP. What we need to do is something very, very simple. All we need to do, interface L0, do show run interface L0, just so we can see it. We'll say VRF forwarding and pop in the name. And all we need to do is go ahead and put the addresses back. Do show run interface L0. Okay, now you're seeing line protocol drop for tunnel 1. We have a DMVPN tunnel up and running in the background. We were using that for RIP version 2 to demonstrate the split horizon. So ignore this error message, not the end of the world. So now you can see that we've now taken this loopback 0, we've removed it from our global routing table, and we put it into the RIPng forwarding table. We've put the addresses back. Let's go over to router 2. And boom, there it is. Actually, let's unall so we don't continue to get the debugs here. And now you can see that we've received an update, and it contains the loopback address for router 2. Let's say show IPv6 route RIP, and now we have it. So this is how we need to configure RIP in a VRF. Don't forget, let me just jot down the notes here. You need to enable this globally, but not just with the process. You need to actually enable the VRF mode globally, and then you can go ahead and you can do everything else that you would normally do. And also remember that in order to run a VRF in IPv6, you need the VRF definition. Okay? Hope you guys enjoyed the video. See you next time.